operations are also relations. Addition, differentiation, etc. So we will discuss about these things and we will explain them using examples. So a mathematical statement is a statement about mathematical objects and relationships between these objects. So these are some types of mathematical objects. Numbers, we already know about numbers, but these other objects we will come across in when the time is right. Addition we know, differentiation, these are from calculus. Okay, functions, matrices, differentiation, this is from linear algebra. So those things we will come across. Now let us go through some examples. We have already seen two mathematical statements which are rather dull, and still we are going to go through some simple and dull statements, but we have to understand what we are trying to say here. For example, this is a mathematical statement. This is a mathematical statement which is of course true. So I can write T to represent the fact that it is true. Another statement is 2 plus 2 is equal to 5. This is false. Nevertheless, it's a statement. Although false, it's a statement because it has these things are called truth values. Truth values of a statement. A truth value is either true or false. So a statement has a definite truth value. Now, any combination of mathematical objects and relations is not a statement. For example, this is not a statement. This is not a statement. It has to make sense. This does not make any sense. This combination of the mathematical objects, that is numbers and symbols, this does not make sense. However, these two make sense. Okay, so the statements which make sense, they are called well-formed or well-defined, and the statements which do not make sense, they are called ill-formed or ill-defined. Now, of course, we are concerned about well-formed statements and that too about true statements. However, sometimes we will come across false statements, and surprisingly we will see that false statements also are useful. Okay, but ill-formed or ill-defined statements, they are not in fact considered statements at all. That's why not a statement. We do not assign any truth value to an ill-formed or ill-defined statement. It is neither considered to be true nor false because we are not concerned about them. We discard them. They are useless for us. Now, one thing that I have not told you while discussing about mathematical statements is that these objects, here you see that the objects are constants. However, the objects can be variables also. For example, I can write a mathematical statement like this: x plus 2 is equal to 3. Here x is a variable. We don't really know what x is. Now, this statement as such cannot be determined to be true or false because nothing else is said about x. Note that I am not talking about solving this equation. That is an entirely different matter. I am talking about the statement itself. So it contains mathematical objects. For example, x is a variable, 2 and 3 are constants. So these are mathematical objects. There is a mathematical relation. So these relations are there. So this is a well-defined mathematical statement, but still we cannot determine just like that whether it is true or false, because its truth or falsity depends on x. When x is equal to 1, it is true. Otherwise, it is not true. So we will talk more about variables later on. We will come to that. So just like these numbers, if my mathematical statement contains functions, vectors, matrices, that may also not be constant. That may be variables also. So, sorry, excuse me. So we are concerned about well-defined mathematical statements and their truth or falsity. So that is basically